Very good evening, everyone. Welcome to the class.
Good evening, sir.
Very good evening, Subhajit.
Good evening, sir.
Mohammed Azam, Likit,
Good evening,
Nukul,
sir.
Hardik. Very good evening. Nice to see everyone for a 5 p.m. navigation class.
Good evening, sir.
Pleasant surprise. Nandini, pleasant surprise. Nice to see you all attend the lecture. Nukul, good evening. Hardik, good evening, everyone. Couple of minutes, we'll settle down, and our point of concern should be on what we had covered about gyros in our previous class. If you have any questions, you will ask. Okay, we are not going to waste any time today, but we are going to focus on solving your doubts, and we are going to cover up basics of gyro. Along with that, we also need to know if we understand the basic principles. What are the basic principles? Achal, welcome to the class. And I think Viral will also be joining us. Manan, are you there? I think Manan has not joined us yet. Very good evening, everyone. Hardik and Achal, and Nandini, Likit, let me know if you have gone through the earlier lecture before this lecture. Basic principles of gyro.
Yes, sir, I see.
Okay,
No,
good.
sir.
Hardik, how about you?
No, sir, nothing.
Nothing.
Navigation.
Nothing. Okay, no problem. So Hardik, for you, whatever you understand, good. Whatever you don't understand, it's okay. Today also we are covering basics. CPL is all about basics only, but still, if you feel that something you don't understand, just put it in the parking lot for your navigation. This is an extra class for you. You will be given a fresh set of lectures for your batch also. So today's agenda is for you to learn extra and utilize the time that you have. So don't think that we are starting midway for you. For you and for Archel, it's going to be extra. Okay, is that clear? Whatever you understand, you will write down. You will make notes and study. Whatever you don't understand, you can ask me directly, and you can write the doubts in your parking lot of the notebook for navigation. All right, Hardik.
Roger, sir.
Okay, great. Now, there are a few things that are very confusing when it comes to gyro. First things first, you can either call it gyro or you can call it gyro. It's up to you. Different places, different people pronounce it in a different way. All right. Australian English is different. American English is different. And the UK, Britain English is different. So if you say gyro, it's fine. If you say gyro, it's fine. If you say gimbal, it's fine. If you say gimbal, it's fine. With us, it's everything is fine. Okay, you can call it gimbal also. Gimbal system is the system of all the arrangement of gyros within each other. So today I'm going to break everything down into simple words. Today you have to have utmost focus on what we are talking about when it comes to gyroscopes. The scope of your syllabus for CPL, gyroscopes, is limited. If we are referring a classic textbook like Oxford Academy textbooks for our reference, then over there what we have in gyros is over and above what we need to do. So it's a matter of extracting the simple and the basic principles out of the content and then learning those. So after we are done, when I'll be sharing books with you to read, make sure that you avoid focusing more on things that we have not covered, but you can just read them once and go through the keywords or make a few pointers or notes for certain keywords that you think could be important in the examination. Other than that, whatever notes I'm giving you will be more than enough for you to, perform well when it comes to gyroscope or aircraft instrumentation. All right. I'll reintroduce gyro today, and not in shortcut, but we'll be talking about gyros with the help of flowcharts. So I'll be making a flowchart on the whiteboard. One by one, I'll explain everything. You have to do the same. Viral, welcome to the class. How are you?
I'm good, sir. How are you?
I am good and such a pleasant surprise today to see everyone back. Viral, welcome and welcome to a live session. Are you working alongside this session or are you not working right now?
No, not working right now.
So you have a break or you're done for the day?
Done for the day.
Wow, that is good. That is good. Viral, have you seen the last lecture? That is basic gyro principles.
Perform.
Good, 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 good. All right. Before we start, anybody has any questions? Let's first talk about them and let's first discuss those. Subhajit, do you have any idea? Have you gone through the basic gyro principles lecture?
Yes, sir. Today afternoon at itself, I was looking at the lectures.
Very good. Any questions or doubts?
Also, nothing as such. We'll see if some doubts arise in today's class.
Okay. Likith, how about you?
So no doubt, sir.
Have you attended first lecture for gyro?
From sir, I've checked on YouTube.
Sorry, Likith, say again.
I've done it on YouTube, sir.
On YouTube. Okay, you had attended it on YouTube. All right. No doubts, right? Mohammad Azam, Nukul, if you have any doubts, please discuss.
Negative, sir.
How about you, Nukul?
Negative, sir.
Viral and Nandini. Nandini, did you go through the previous lecture?
Yes, sir.
Any doubts?
Negative.
Okay. Finally, Hardik and Anchal. Any doubts or any questions that you have based upon gyros? Not necessary based upon whether you have attended the lecture or not. Any generic doubt is also fine.
Sir, I don't know what is it.
Okay. All right. One more favor I need. Can someone just send me a picture of what you can see on your screen and share it with me? Make sure. Nukul, can you do that if you have two devices? So I want to see the entire thing that you can see apart from me. I want to see the surroundings that you can see. Okay. Because I cannot see how much is the span of the picture of my video. Although it's 1080, what do we call it? HD, but I'm not sure how much you can see. I can only see a short part. Someone else also, if you can do it along with it. Okay, Hardik has done it. Thanks. Subhajit, Mazam, thank you so much. Okay, this is what Hardik has sent. Okay, what Mohammed has sent. Okay. All right, fine. Today I'm actually, squeezed into one corner. Even my right hand doesn't have freedom, but it's okay. Good. Thank you so much. Okay. So gyro basic principles, gyroscope, anything that rotates, if the RPM of that thing while it's rotating, if the RPM is high enough, then that particular thing can maintain its orientation in space or in earth. What does it mean? It means that a toy, a small toy like a playing toy, if you know a toy, a spinning top, TOP top, when you spin the top using a thread, the top is always standing vertical till the time it's rotating. The moment the rotation stops, the top moves like this, like this, like this, and topples down. That is your basic gyroscopic principle. Anything that rotates. Okay, so we are talking about a disc in gyro, which is a disc like this, a metal disc. Okay, the rotating disc at a very high RPM will be at the core of every gyroscopic instrument. I'm going to show you all instruments today, all the applications. All these instruments inside the mechanism have a rotor like this, either a disc type rotor or a drum type rotor, a rotor that is huge in thickness. This rotor rotates at a very high RPM, and because of this rotation, what you will come across is the spin axis. The axis around which, imagine the pencil to be the axis. The rotor is rotating at a high speed. When the RPM is enough, it possesses a gyroscopic property known as rigidity, which means it stays rigid in one position as long as it is rotating. And the reference that we get is the reference of this axis of the spin, which is this axis. Now let's assume if I can rotate this rotor at a very high speed to get gyroscopic properties, the name of that property is rigidity, then my point axis, the point of axis will be constant or rigid in one direction all the time. Okay. The rotation of the disc will make sure the gyro is holding its position, and with relevance to your instruments, we'll be talking about this axis of rotation. So if my gyro is like this, when the axis is vertical, this is called a vertical axis gyro. Vertical axis gyro can topple down when they are not moving at a high RPM. While when I show you a gyro like this, where the axis of rotation is horizontal, it's known as horizontal axis gyro. The horizontal axis gyro is applicable in almost all your instruments. If the RPM is high, the axis is maintained fixed in a constant direction. What does it mean? It means that if I align the axis of my rotor along with the longitudinal axis of my aircraft, like this, when the instrument is inside the aircraft and the axis is aligned with the aircraft, then if my aircraft will turn like this, the axis would still remain in the fixed direction because of the gyroscopic properties. If my aircraft will move like this, the axis is still going to remain straight due to the gyroscopic properties. If my aircraft is pitching down, my axis is still going to be straight because of the property of rigidity. That is your gyroscopic property called as rigidity. Rigidity is very important, and rigidity is directly proportional to your RPM, the mass of the rotor, the inertia of the rotor, all those things. I'll be giving you all notes in writing. With the help of this steady reference, if I want to measure, let's say, pitch up angle, from the side, the pitch up angle looks like this. This is 0 angle from the horizontal. This is pitch up angle, maybe 10 degrees, 20 degrees. Having this horizontal reference and measuring the aircraft movement about the horizontal reference can help me measure the angle of pitch up or pitch down. Similarly, if this is the horizontal and this is the aircraft, I can measure the angle of bank also. This is bank. Provided my rotor is moving in this direction and my axis of the rotor is horizontal. Or maybe I'll take a vertical axis gyro and keep a gyro rotating like this and keep the aircraft like this. Whenever the aircraft bends, the gyro will hold its rigidity position. Basically, gyro gives you a standard reference. And that reference is taken as the aircraft reference while the aircraft is allowed to move, but the instruments will show you the horizontal or the vertical reference and how much has your aircraft moved right or left of that particular reference. So gyroscopic instruments are going to give you certain measurements with respect to aircraft attitude. And it's not that attitude that is associated with an ego. Here, the attitude means whether the aircraft is straight and level, whether the aircraft is climbing up or climbing down, whether the aircraft is banking right or banking left, whether the aircraft is turning right or whether the aircraft is turning left. These are the attitudes. And how do we get it? We get it because of gyroscopes, instruments related to gyroscopes, wherein the inherent mechanism is a rotor moving at a very high RPM and at least one axis. That axis will always be there. If I want two motions and I want an instrument like artificial horizon where I can measure roll and pitch together, so I will use this, and along with this rotor and the axis, I will have one more ring like this over here called as gimbal ring or gimbal ring, inner gimbal. If you add gimbals, your motion in planes increases. You have 3 planes of motion in an aircraft. Longitudinal axis gives you 1 plane, vertical axis gives you 1 plane, and lateral axis gives you 1 plane. So questions come in the exams like which gyroscopic instruments gives you how many planes of motion, how many degrees of freedom, which gyro is fixed in reference to space, in reference to earth, or with reference to any other specific heading that we want it to, for which we want it. Okay. Are you able to understand what I'm trying to say? I'm laying down what we are going to study in the simplest of forms. Hardik, do you understand what I'm trying to say? Anchal, do you understand what I'm trying to say? Likit, Mohammad Azam, Subhajit, you're feeling sleepy? Tired?
No, sir, actually, I'm having some discomfort in my eyes. Like I can't stare at the screen for so long.
So you follow
It's,
the voice. You keep
Yes,
the
sir, I'm trying to do that
yeah,
only. That's why I'm looking some other sides.
yeah. Close your eyes. If I share whiteboard, then you open your eyes. Okay, students. So in order to understand what I'm going to teach you about gyro, okay, you have to understand that this is the aircraft straight and level. For the pilot, this is the vision of the aircraft. This is what the aircraft looks at. Pilot will look in the instruments. Which instruments do you have an aircraft symbol? There are 2 instruments where you will have aircraft symbol. Basically, all 3 gyro instruments have aircraft symbol in them. The first one is directional gyro, also known as gyro compass. Okay, I'm going to show you pictures. The second is attitude indicator or horizontal artificial horizon. That also has a small aircraft inside. And the third is turn coordinator. That also has an aircraft symbol. So gyros are there to show you that you are parallelly horizontal to the surface of the earth. Basically. Second reason the gyro is there to show you whether your bank angles are within limit or not. Okay. Third thing that the gyro will show you will be accurate magnetic headings by using gyro and magnetic compass together. There are certain errors in a basic magnetic compass. Okay, we use magnetic compass for navigation, but it has certain errors during turning and during acceleration, where the readings are not accurate. Combining a magnetic compass with gyroscopic principles gives us a DGI, directional gyro indicator, where we will use it as a compass only, in which we will not have any turning errors or acceleration errors. Okay. I will be giving you all a list of turning errors and acceleration errors also before you go for the examination. Remember, although it's not a part of your CPL agenda, but we'll still do it. So using gyros, what we actually get, you have to remember that with respect to the earth, wherever you are, using gyro with respect to the earth, you will remain straight. If your earth is bending like this, still you will remain straight. If your earth is bending like this, still you will remain straight. This is rigidity. And we need this rigidity to have a stable reference. Okay. We are going to break down the understanding of gyro in smaller levels and level 1, level 2, level 3. So today I'm going to discuss and give you notes about first the basic principles, including rigidity and precession. And what is precession? Something that confuses a lot of students. My gyro, in order to perform well, it has to maintain its axis. Let's assume this horizontal axis, and it has to maintain its motion like this continuously. No disturbance from external side should be impacting my gyro. But let's say there is a force called as torque on the axis of rotation like this force. Now precession is something that is opposite to rigidity. I need rigidity for references. Rigidity is what basically gyroscopic property is all about. But when rigidity is less, there is something called as precession. Let's say there is an external force torque acting here. This force from here will be transferred to this part of the disc, and it will try to bend the rotor like this, but the rotor is not going to bend. Now, when I show it to you like this, the point that you have to remember about a force called precession, that is opposite to rigidity, is that when the torque is applied to the axis, from the axis, the force is applied here. And from the force, the precession acts clockwise 90 degrees. And it will bend the rotor here. So if my axis was like this, because of this bend, my axis will become like this. So if I show it to you from here, this is the torque. This is where the force is applied. And 90 degrees in the direction of rotation, this is where the force acts. The moment the force acts, it will be bending like this. It means my axis of rotation, which was rigid, is actually drifting away to the left side. This is known as wander. Horizontal wander is known as drift. Wander is basically error in your rigidity of your gyroscopes. WANDER. And there are types of wanders. It means types of errors. If you have attended a few lectures of navigation, you would know something known as drift and heading, and difference between drift and heading. Right? That drift is the difference between the longitudinal axis and your track, right? That we can say that is drift. Here also, if you have a longitudinal or a horizontal axis gyroscope, you will have wander that is called as drift because of any external force. The force can go downwards also. If the force goes downwards, it will act here, and 90 degrees in the direction of rotation, the force will act here, which will drift my axis to the right side. This is called displacement, drift or displacement. Okay. Now, in order to keep my gyros steady, I can tie down, TIE, tie down or restrain the axis by external means also, by modes of springs, or I can use the Earth's gravity. So they are known as tied gyros. The reference is tied to a fixed plane or a fixed reference. Hardik, are you able to understand?
Nothing much, sir, like very less.
You have to just listen and try to imagine. So what are the doubts, Hardik, so far?
Sir, like I'm just listening and like I'm not able to understand.
But what is it that you can understand? Something? Nothing?
Almost nothing.
Focus on what you have been able to understand. Tell me that. I'm just talking, exchanging information. So something you must have understood, right?
No, sir.
What? Tell me something. Come on. Yeah, Hardik. There is no right or wrong answer to this. Share your views. Don't be shy.
Sir, like gyroscope, I like something related to axis.
What about the point where I said every gyroscope has a rotor and a rotor axis? What about that point?
No, sir, I don't remember.
Okay, focus, Hardik. It's not like it's not meant for you. Learn something at least. Focus on these points, right? Okay, everyone, focus here. Hardik, try your best to understand. Don't focus on what you can't understand and ask questions. Simple. It's your first class. In future, you have to do this. You will reach this level. Don't worry, okay? You will reach this level. But today, try to understand something at least. Okay?
Okay, sir.
Yeah, just try. Enjoy this. You will be one step ahead in your training in future. Okay, this is something that was covered in the previous lecture. So Hardik, before the next class, you go through the previous lecture after the session is over. It will make more sense to you. And just use your time to study. It's not like you have to study it, but it's an option for you. Remember that, okay?
Okay, sir.
Otherwise, we will be taking you in the fresh batch only. Just an extra thing for you, whether you understand or not. But I don't want you to be sitting here wasting your time and not study anything. If you feel you're not understanding anything, then you can leave the class also. I'll not feel bad. But if you're sitting, then try to learn something at least, okay? Following, right, Adik?
Affirm, sir.
Yeah, good. Stay. Give your best. It takes time, but you will get there. All right. Gyro basic principles and all. I'm just showing this to everyone. What are the types of gyro and all? It's okay if you don't look at it. It is only for those students. Hardik, please write this. Make this. Every aircraft has 3 axes. Longitudinal axis going from nose to the tail of the aircraft. Lateral axis going from wingtip to wingtip. Okay. And vertical axis on the side aircraft I have shown, which passes through the confluence of the longitudinal and lateral axis. All these 3 axes are mutually perpendicular to each other. Okay. And the movement of the aircraft also happens along these 3 axes only. So longitudinal axis is from the nose to the tail. Lateral axis is wingtip to wingtip. And vertical axis is going straight from top to bottom. All 3 axes pass through the CG of the aircraft. So let's start. Any questions, students? What is a gyroscope? Any rotor possesses gyroscopic properties. Are you following this point, students? I want you to understand gyroscopic principles. I want you to understand gyroscopic principles to this basic fundamental. Every rotating object will possess gyroscopic properties. And that property which we need is called rigidity. Hardik, are you following?
Affirm, sir.
Can you just rephrase this sentence? Can you just repeat? Give me a readback of the sentence.
No, sir.
Every rotating object possesses gyroscopic properties. Simple. Everything that rotates possesses gyroscopic properties. Yeah, Hardik, give me a readback quickly.
Forty-six, sir.
Yeah, thank you. Hardik, are you speaking?
Sir, I was not able to listen you.
Every rotating object possesses gyroscopic properties.
Okay, sir.
Can everybody see the screen?
Affirm, sir.
Affirm.
Any rotating object possesses gyroscopic properties. These are, what are these properties? There are 2 properties. Number 1, rigidity. And number 2, precession. Rigidity is what gives a steady reference for measurement of essential properties or aspects of aircraft like roll angles, bank angles, pitch angles, balanced turns, rate of turn. Rate of turn, you'll write rate 1 or rate 2. Why do we need gyroscopic instruments? We need to make sure that our roll or bank angles, our pitch angles, our turns. So roll and bank are actually the same. Pitch angles, I'll show you what is a pitch angle. Balanced turns, I'll show you what balanced turns are. Rate of turn, you have to take turns as per rate 1 or rate 2 only all the time. Even when you'll fly as a pilot, you'll be doing rate 1 or rate 2. I'll tell you what are they. And reference for measurement of aircraft heading. Okay. Now, roll and bank and pitch angles. Okay. You have an instrument called as artificial horizon, also known as attitude indicator. Okay. For balance turns and rate of turn, rate of turn indicator and slip indicator, also known as turn and bank indicator. And these are primary aircraft instruments. Okay, so gyroscopes are primary, gyroscopic instruments are primary instruments, you could say. Aircraft turn and bank indicator. And last one, reference for measurement of aircraft heading, DGI, that is directional gyro, also known as gyro compass. These are the applications. Simple. Students, are we understanding this much? This is the first classification. This will make your job of learning gyros much more easier. Okay, this understanding. Don't mind, Hardik, if I'm calling out your name again and again. Okay, I'm just checking if you have started to follow things or not. Don't feel bad. Hardik, are you able to understand this much now?
Yes, sir.
Okay, good. Keep putting your efforts. Thanks. Any doubts so far? Nandini, how much did you miss?
Nothing, sir. I watched on YouTube.
Okay, fine. Good job. So here, these roll or bank angle and pitch angle is important to be measured. And the instrument that we have is a gyroscopic instrument called as artificial horizon or attitude indicator. Okay. Now, whether my turn is balanced or not, and what is the rate of my turn, rate 1, rate 2, am I maintaining the rate or not? That is also represented by a gyroscopic instrument known as rate of turn indicator and slip indicator, or a turn and bank indicator, different names given to similar instruments. And for aircraft heading, checking the heading and measuring the heading of the aircraft, having a good reference to measure the heading of the aircraft, I have a gyro instrument known as Directional Gyro Indicator or Gyro Compass, which is a gyro combined with a magnetic compass. It's free from the errors of a magnetic compass. So eventually, over the lifetime of your career as a pilot, these three instruments are very important to you. Okay. Whether your pitch angle is correct or not, whether your bank angle is correct or not, whether your turn is correct or not, whether your turn is balanced or not, whether you've got the correct heading or not. So these are primary instruments. So in aircraft instrumentation, in the cockpit, you have basic 6 layout. Some people also call it a pilot's 6-pack. Okay. Out of this basic 6 layout, 3 are gyro instruments, while 3 are air data instruments. Okay. So we are talking about gyro instruments. What are these gyro instruments? I'm going to share. I'm going to show you some pictures. Is everybody with me? Students, only one student has a video on. Others, if you can keep your videos on, let me know, or please keep acknowledging. It should not be like what I'm teaching is falling on deaf ears, okay? It's a very important topic. Learn and understand properly. So far, is everyone on the same page? Hardik, keep writing your doubts. Keep sharing it with me on WhatsApp as and when they come.
Sir, can you repeat those 6 things?
Can I repeat what?
Those 6 things.
Yeah. In cockpit, basic 6 layout, 6-pack, 6 primary instruments to show important aircraft characteristics. Flight characteristics, I would say. Three are air data instruments. Mohammad Azam, have you done air data instruments?
Not yet.
No problem. And 3 are gyroscopic instruments. Okay, everyone. So far, so good, everyone. Anyone finding it difficult or technical or over your head, you will tell me. Hardik, you are also allowed to speak your doubts, okay? Everyone is. But if you are just sitting and just listening to me without understanding, thinking you will read the textbook and understand it on your own, then that doesn't work with me, okay? That doesn't work well. I hope the instructions are clear, all right?
Yes, sir.
Okay. So this is the basic 6 layout. Can everybody see the cursor?
Yes, sir.
Mouse pointer? Okay. First, look at the left instrument on your left side. This is known as Airspeed Indicator. It's an air data instrument. Students who have done air data instruments, are you able to recollect everything? The minimum and maximum speeds and the color coding of the arcs and everything, students? Yes, no, maybe you should do it. Yes. The one on the extreme right where the cursor is altimeter. It's a triple pointer altimeter, very confusing to read. Okay. Then the right one on the below right corner is the vertical speed indicator. These 3 are air data instruments: ASI, airspeed indicator, altimeter, and vertical speed indicator. Okay. And now let's come to the gyroscopic instruments. This one that shows you blue sky and brown land mass is your artificial horizon. Okay. This bar over here, can everybody see this bar pointer index? This will show you your bank turns or rolls. 10 degree, 20 degree, 30 degree, 45. Every graduation has a meaning. 10, 20, 30, 40, 50. maybe 90. This up to here is 90 degrees, up to this point. And these lines, they show you pitch angle. You're on 0 right now. The aircraft is straight and level. If you're pitching up, this yellow wedge type thing is the representation of your aircraft. 0 pitch angle. If this line will coincide with this line, it will mean 5-degree nose up. If this line will coincide with the 10 line, it will mean 10-degree nose up. 15-degree nose up, 20-degree nose up. Similarly, when the aircraft is down, 10-degree nose down, 15-degree nose down, 20-degree nose down. This is called as your artificial horizon or your attitude indicator. This will show you bank or roll angles, and it will show you pitch angles as we have written down in our notes. Artificial horizon. Everybody with me on this? Even when you look at, now this is an analog cockpit, okay? In case you look at a digital cockpit and the primary flight displays, in the display also in the center, you will have artificial horizon. On the right, you will have a vertical altimeter scale. On the left, you will have a vertical airspeed indicating scale. Now come on the bottom of horizontal artificial horizon. This with the aircraft symbol is your gyro compass or your directional gyro indicator. It looks just like your magnetic compass with all the lines, all the directions. North, east, south, west. So this is the aircraft heading presently without any errors, giving you instantaneous readings. Normal compass has a lot of errors during turning and acceleration. So we take this, we use this compass. So this is DGI. It gives you a reference to measure your heading, shows you aircraft magnetic heading. What is artificial horizon showing us? The bank angle and the pitch angle. What is DGI showing us? Giving us references to measure heading. Come on the left. This instrument. This instrument has two components. First, to measure the rate of turn. Okay. The aircraft symbol here shows no turn right now, 0 bank angle. Then there is another graduation here. It could mean rate 1 turn in this instrument. Maybe it's only designed for rate 1 turn only. Why we know rate 1 turn? Because rate 1 turn takes 2 minutes to complete 1 circle. Remember that. I'll talk about it when I give you notes. So this aircraft will show you turn whether you are banking towards the left or banking towards the right. Aircraft is like this. You look at the aircraft from behind. From your perspective, this is left. This is right. Banking left will initiate a turn to the left. Banking right will initiate a turn to the right. So always the perspective is that you're moving forward and the aircraft is straight. You're going straight into the aircraft like that. This ball is known as a ball type inclinometer or inclinometer. If your turn bank angle is optimum, then the ball will remain within the glass tube. It's a glass tube. It is filled with a liquid that prevents oscillations. There are no oscillations. It's like a spirit level only, but it's designed to measure the aircraft turns. Let's say your bank angle, safe bank angle is 22 degrees for your particular aircraft for a particular task. If your bank angle is safe angle is 22 degrees, and if you are banking 22 degrees, then the ball will remain in the center. If you are more than the actual bank angle, then the ball will slip. If you are less, then the ball will skid. Slipping means getting towards the center of the turn, and skidding means going away from the center of the turn. So how much slip do you have? How much skid do you have? Is your turn balanced or not? So these 3 gyro instruments together give us 4 functions. Balanced turns given by this inclinometer, simple ball and a tube type. Rate of turn given by this aircraft and its graduations known as turn coordinator. Then DGI giving me heading references, and then artificial horizon helping me measure bank angles and row pitch angles, not roll, but pitch angles. Do we understand the application, students? What is the application and what is of utmost importance to the pilot in the cockpit? This layout is known as basic 6 layout. It's a common term given to instruments laid out like this. Basic 6 layout of instruments in the cockpit. Okay. All these instruments you can consider are essential for your flight characteristics of the aircraft. Any questions so far? I don't want to rush these topics. Mohammad Azam, go ahead.
So what is that push in the DGI? Yeah, oh there.
Yeah. So airspeed indicator has a knob, DGI has a knob, and artificial horizon can also have a knob. So we'll come to it. Why do we need it? The problem with gyros is that when you start the aircraft, engines, the rotors inside the gyro, they also need to be rotated at an optimum RPM level. Okay. And it takes time because in order to rotate the rotor, you have multiple options. You can use suction of the air, you can use vacuum, or you can use electric motors in the rotors. So all that takes time. Depending upon which type of rotor you are using in your gyroscopic instrument, we need to give some time for the gyro to align with the reference for which it is tuned. Like directional gyro might be referenced with certain point in space. Artificial horizon might be referenced with something. Turn coordinator will be referenced with something. So we need to give it some time to get erected. So the time for erection of your gyroscope is basically giving the rotor enough RPM that it stabilizes on its own like this. So the knobs are for that matter for every gyroscope. So students who have done a glass cockpit or flying, they will know that, sir, before I would request for takeoff 10 to 15 minutes before I would align my artificial horizon. So that alignment happens, you give some time, you start the engines, you start your generators, whatever power sources you have. And first make sure all your gyros are powered correctly. It means all rotors are rotating. It takes some time. Some old type of gyros take around 10 to 15 minutes to stabilize. And if you have heard about inertial reference systems or inertial navigation systems, then they are advanced electronic gyroscopic instruments that help you with autopilot systems and so on. But we have to just learn about gyroscopic basic principles and basic type of gyros and basic information about these gyros. Are we clear? Viral, Subhajit, Hardik, Likit, Aanchal and Nandini?
Yes, sir.
I think Hardik is having a tough day today. Hardik is like, ये मैं कहाँ आ गया? कुछ समझ नहीं रहा है मुझे. Yes, Hardik. Do you understand Hindi, Hardik?
Yes, sir, definitely.
ऐसा ही फील हो रहा है ना आपको?
पहले हो रहा था, अब थोड़ा नॉर्मल लग रहा है.
वेरी गुड, वेरी गुड. मुझे तो लग रहा था कि मैं आपको बोलूं आप बाद में अटेंड करो, आज अटेंड मत करो. आपको अच्छा लगता है क्या मैं ऐसे बोलता तो?
नहीं मतलब it doesn't matter.
It doesn't matter. Very good. Good. Don't feel like that. Okay. थोड़ा बहुत भी पढ़ोगे आपको. ये resilience initially you have to establish. Others have done a lot of this. Everybody you see sitting calm and understanding everything, they have toiled hard. They have studied with me and they have developed it. You know, Hardik, you will also reach there. Don't worry. Okay, fine. So far so good. We know the applications. Now let's come back and discuss gyroscopic properties with notes. I'm going to give you notes. I'm going to write them also. With me you write and with me, let's see whether you understand or not. Today's agenda, if we are able to finish the basic properties of gyro also, and if we are able to differentiate between the types of gyro also, which is very confusing, and if we are able to differentiate between the types of wander also, which is also very confusing for a student, then it will be like 2 or 3 hours spent very well. Okay. But we'll not be rushing. But Lokol is like, sir, 3 hours. What did you say? 3 hours? I have to go somewhere in the evening. Okay, Nukul, no problem. You can leave whenever you want.
No, sir, no.
Okay. The good thing is you don't want to get into the actual functioning. Okay. Like how does which gimbal ring displaces how that you get that indication in the cockpit. That is not necessary for you. Okay. We don't need to get into that much, but you need to understand the displacement of the reference. It happens because of the errors, and the errors can be of n number of reasons. So I would suggest that you read the text that I'll share with you whenever I share with you at the end of all the training sessions for gyros. Okay. And in the text, it will I just want you to read that once, extra information, which I'll not be covering in class. How do you think you are able to balance a scooty or a cycle if you know how to ride a cycle while moving? But why can't you balance a cycle when it is not moving, when it is stationary? Who can tell me why? Likit, what do you think? Hardik, what do you think? Anshul, what do you think? A cycle. A cycle, if you don't ride a cycle, if you keep it stationary, when the wheels are not moving, the cycle cannot stand erect without a cycle stand, a bicycle stand, a two-wheeler cycle. Okay. It will fall down. It will topple. Okay. Why? And the moment a person sits on it and starts pedaling, the wheels start moving, that the cycle is able to stand erect without any stand, without any support. The same happens with two-wheeler bikes and scooties also, right? Why? Who can share with me? Subhajit? Subhajit, days are back, One day, one student was like, sir, I asked one student that, how did you come to know about me? So student is like, sir, I have seen your videos on YouTube. It's very nice. I'm like, wow, have you studied anything? So you're like, sir, yeah, I understood this. I'm like, okay, good. Then he said something like, so that Subhajit class I have attended. I'm like, yeah, you have attended navigation class, 5 p.m. classes. Because Subhajit is the person who always gives answers first, more than any. He doesn't give chance to others to give the answers. So I remember Subhajit is very famous that way. Hussain used to be famous because of his doubts. I remember students used to put it on chat on YouTube that Hussain thoda padh ke aaya kar. The day I saw it, I felt so bad about Hussain. I stopped people the access to leave chats also. It's discouraging, right? Like they don't know what it is. They are studying. So you don't take it personally, but yeah, these things happen. So after a long time, we are doing Subhajit today. Subhajit, no, wait, let others also share the limelight with you. Viral has given us an answer in the chat box. It has gyroscopic property, motion, gravity, and rigidity. Okay. Likit is saying because wheel are rotating and act as gyro. Exactly. Likit, good guess, or a good calculated guess, I would say. Because the wheels are rotating, and the rotation of the wheels induces the property of gyroscopes. Which property? Rigidity. And the tires or the wheels of your bicycle are like horizontal axis gyros because the axis of rotation is horizontal. So when the aircraft falls down, it topples. When the bicycle falls down, it topples. Rotation of wheel induces rigidity. Okay, good. Hardik, what do you think now? Why do you think a cycle will not fall down when it is being ridden by a person?
So because of gyroscopic properties.
And how do we get the gyroscopic properties in the cycle? Because of the rotation of the wheel. Okay. Because of the rotation. You have to remember, students, high speed rotation, gyroscopic properties. Which property? Rigidity. Okay. And what affects rigidity, opposite to rigidity, is precession. Not good. Not good for us. And due to precession, errors happen known as wander. Wander is a special word given to gyroscopic errors. Now, wander can be of different types. Simple. Okay, that is something that we are going to discuss. Okay, good. Any questions so far, students? No? Okay, so we'll take a short breather and we will start. I'll be discussing as well as I'll be giving you notes. First on basic principles, and then we will go into dividing the different types of gyros. So the notes are in three parts. Everything we cannot cover in today's session. First, basic gyroscopic properties. Second, the differentiation between types of gyros and types of wander in a gyro. Third, the differentiation or important properties of all the four gyroscopic instruments known as artificial horizon, DGI, turn and bank indicator, turn coordinator. All right. This is how we'll simplify our learning in gyroscopes. So we'll come back in 10 minutes, students. We'll take a short breather and come back. One 807 hours. Okay, a 10-minute breather. Refresh and come back, everyone. मैंने ब्रेक लिया है 10 मिनट का बोल कुछ काम है तो Okay, welcome back, everyone. Let's confirm if everyone is back. Okay, Viral, Nukul, Mohammad Azam, Subhajit, Hardik, and Nandini. I think Likhit and Aanchal will be joining us. Okay. Mohammad Azam, if I have to ask you what is a gyro or gyroscope, how would you start your answer?
So it's an instrument. I'll start with an instrument which has two different parts. It has a gimbal in that, lower gimbal and upper gimbal with an axis with a rotor. The rotor has a rotor which is fixed to an axis. So gimbal which controls the rotor.
Okay, okay, fine. All valid points. Nukul, if I have to ask you, what would you say the gyro is? What would you say?
So the gyro used to maintain a stable as you can say, to maintain a aircraft stable, or it will give the information about pitch of
No,
the
Nukul, good effort, but you cannot say it is used to maintain an aircraft stable. No, that
give the
is
information.
okay, okay.
Well, is give the information about aircraft. It's while it's pitching up or down or rolling down or banking.
Yes, okay. Somewhere there, all right. Viral, how would you describe gyroscopes?
It determines the attitude of the aircraft.
Okay, that is way too specific. Only I'm talking about generic gyroscope. Good, fine. Nandini, how would you describe gyroscope as?
It is a rapidly spinning rotor with an axis. It can be horizontal or vertical.
Okay, fine. Aanchal, how would you describe a gyroscope? Hardik, Aanchal will type in the answer. Hardik, you tell me verbally. How will you describe gyro in your words?
So a spinning rotor that would tell angle or axis. lead.
Good, not bad. Aanchal, waiting for your answer. Good, not bad. Spinning, rotor, angular, axis, fine. Something or the other. Nobody has given me a perfect answer. But you have to reach that point where you understand. All right. We cannot rush. Gyro is in itself a unique subject altogether, but it's limited for CPL. Okay. You can understand 3 to 5 marks maximum in a 100-mark paper, maybe 7 at max. Okay. Likhit, coming to you, how would you describe a gyro in simple words? Yeah, Likhit, are you there?
Stand by.
Yeah, I am standing by. Write down. What is a gyro or a gyroscope? Write down the answer. Any rapidly spinning symmetrical rotor has gyroscopic properties. Any rapidly spinning symmetrical rotor has gyroscopic properties. Okay. We have an answer from Achal. Achal's explanation is instruments having high speed rotation possess gyroscopic properties. This property is rigidity. It's important to maintain the attitude, that is level and heading of the aircraft. Okay, key points are there, but we'll make sure that our answers are more simplified. Instruments having high speed rotation, no. Instruments having a rotor that has a high speed rotation. But yeah, I'm not correcting your answers. I was just checking how much you have understood. Keywords are, everybody was able to give me some of the other keywords. Good. That is a good sign. But now let's look at the ultimate answer to what is gyro. If anybody ever asks what is gyro, you will say any rapidly spinning rotor which is symmetrical. It means the rotor, a rotor disc. This is like a rotor disc, symmetrical in nature. If it's rapidly rotating or spinning, it possesses gyroscopic properties. Like wheels of a moving cycle possess gyroscopic properties, or a spinning top possesses gyroscopic properties, or the earth's rotation also possesses gyroscopic properties. Did you know that, students? Earth also, why do you think earth is fixed in one orientation only, north south? It's because of its rigidity. And why do you think the magnetic north pole keeps moving? Because of precession. Earth has a huge rigidity but a little bit of precession also. Okay. Likhit's answer is any object rotating with a certain RPM with the rotor axis is a gyroscope. Yeah, very good. He can say that. Any object rotating at a very high speed can have gyroscopic properties. You change the word object into rotor. Simple. Okay. Write down second point. Simplest gyros contain a rapidly rotating disc often called as a rotor. Step by step, students. Okay. Next point. Most aircraft gyros are spinning discs. Highlight discs between 2 to 5 centimeters in diameter. So we are talking about the actual rotors inside your artificial horizon, in your DGI, in your turn and bank indicator. The rotors would be somewhere around 2 centimeter to 5 centimeter in radius, only very small. Okay. And RPM, that is rotations per minute, from 4,000 per minute to 55,000 rotations per minute. In some book somewhere it might be written as revolutions, but it is rotation only, spinning. From 4,000 RPM rotation per minute to 55,000 RPM. Imagine, to attain the property of gyroscope, the rotation speed for any rotor has to be super high. Within a second, it has to be rotated 4,000 times. You cannot even count. A human brain, human mind cannot count. You need computers, you need special cameras, you need special equipment. But for a bicycle, you can measure the RPM. For a motorcycle, you can measure the RPM to give you that rigidity. Are we all following? 2 to 5 is the diameter, not the radius, diameter. So radius would be 1 to 2.5 centimeters only. Diameter means from one point to the next point, the total length from here to here, this much, will be anywhere between 2 to 5 centimeters in general. But different manufacturers will have different type of gyros installed. Write down Earth acts as a gyro. In bracket, write keeps north-south fixed in space. Spinning top. You remember something like this, a toy that kids play like this. We use a thread or a rope to, or we get mechanical ones also. I'll show it to you in your next session, because we are going to continue 2 or 3 sessions for gyros so that we study it very effectively. So I'll show it to you in your next. I'll show you practically what rigidity looks like in a top. Spinning top acts as a gyro, only spinning top, okay, not a stationary top. And you'll write bicycle wheels, even unicycle, not just bicycle, bicycle or unicycle wheels act as a gyro. Now let's imagine this. This is a rotor disc I'm making. And this is the axis about which it rotates. If I have to show you Earth, then Earth rotates about its axis, that is polar axis. Earth rotates about its polar axis. Similarly, anything that rotates has its own axis of rotation. This is a rotor. This is the rotor axis. And this rotor axis is horizontal. So this type of rotor is known as horizontal axis rotor. While take example of this rotor over here. Where the spin axis. So this is the rotor. This is the rotor axis. This rotor axis is vertical. So what kind of rotor do I have? I have a vertical axis rotor, and having a vertical axis rotor means I have a vertical axis gyro, and here I have a horizontal axis gyro. Now if somebody asks, or if I ask you, what is horizontal axis gyro and what is a vertical axis gyro, can you explain? Will you be able to explain? Hardik, Aanchal, Hardik, do you think you can explain what is a vertical axis gyro and a horizontal axis gyro?
Yes, sir.
Your focus when you have to understand gyros should be on the spin axis, because that spin axis gives us the reference, steady reference. Okay? Good. Very good. Make these diagrams, write down. Gyros can have, write every statement I'm giving you, write it as if it's a new point. Okay. Learning in point system is the best way to learn. Gyros can have either vertical or horizontal orientation? Gyros can have either a vertical or a horizontal orientation, which is defined as per the axis of the rotor. In bracket, write shaft. Generally, when you have mechanical devices, it will not just have an imaginary line. It will have an axle kind of a mechanical device like an axle. It will have a shaft, and the axis of the shaft or the axis of the rotor shaft or the rotor, these are the terms that you will see. I'm also going to show you a very mechanical gyro today. I'll show you a picture of a very mechanical gyro. Defined as per the axis of the rotor shaft, about which the rotor rotates or spins. Axis can also be defined as the shaft. Remember this, it could be a true and false, mark the correct or incorrect statement kind of a question. Axis can also be defined as the shaft about which the rotor spins. Gyro-based instruments have important applications in aircraft to determine aircraft attitude, roll, bank, pitch. Number 2, aircraft direction. In bracket, you will write heading. Number 3, aircraft turn. Yeah, aircraft turns. All gyros have 2 basic properties that make them useful in aircraft applications. What are these 2 properties? Number 1, rigidity. Number 2, precession. Okay. Students, so far, do you have any questions? Have you understood the basic idea? What is a gyro? What are the types? Horizontal axis, vertical axis. The axis can also be considered as a shaft. Okay. Mohammed Azam Roger. Now, students, what I'm going to do is I'm going to share my handwritten notes with you describing these 2 basic properties. I have made a PDF and I'm going to share with you all. By next class, I want you all to read and try to understand as much as you can. In case there is any problem in understanding any letter or number, you can just cross-check with me sharing a screenshot. Sir, what is this? Up to this point, I have given you via dictation and explanation. Up to which point? Up to this point. Rigidity and precession. You continue reading from rigidity and precession, and it will talk about what is rigidity, what are the elements in rigidity, what is precession, what is RPM, everything. See if you understand it. Okay. Today, for some reason, we have to end the session now. Okay, so we will be continuing from here. But what I would want us to do is try to study the notes. It's like me talking to you, but just through the book. And then we will discuss. Then we will go through the rest of the topic, precession and rigidity, and see if you have any doubts. After that, we'll go on to the description of gyros, and then we'll go on to talking about the individual gyros in basic detail. Okay, understand it's a different science. Gyroscopic principles are a different science in themselves. So before we wrap up the session now, I'm going to share the books with you right now, the notes in PDF that I have converted. But what I want is for you to sit with me for a couple of minutes right now and discuss anything and everything that you can about gyros, about whatever you have learned right now, be it 5%, 10%, 2%. What I want you to try to remember is today, what is measured by which instrument? I have given you those three things. What artificial horizon does, what rate of turn indicator or rate turn and bank indicator does, what DGI does. I'll also be sharing a part of Oxford notes on basic gyro principles as a further reading material for you. Most of our notes will be coming from here only and some other textbooks. But for further reading, I'll be giving you that also to cover basic principles of gyros only. So until the next lecture, that is day after tomorrow, you have to go through both the PDFs, okay? By the time I share the email with you live, please feel free to share or discuss anything that we are talking about gyros with me right now. Whatever doubts you have, please ask so far. If not, then you can simply acknowledge that you don't have any doubts. Radio nav systems, air data systems, gyroscopic systems, they are all having different principles and fundamentals. And for gyro, we need to ensure that our principles are strong, because questions in CPL will come from basic principle and fundamentals only. So I have Nukul, I have Subhajit, I have Achal, Hardik. Achal and Hardik, for you, it's just extra effort, okay? Nothing else. If you can study it right now, it will be great. Mohammad Azam, Nandini. Nobody has anything? No questions, no doubts? Viral, Likit. Achal, Hardik.
Sir, what is this roll, bank, and pitch?
Sorry, say again, Hardik.
Sir, what is roll and bank, pitch? What are these words?
Yeah, look at it. I was showing it to you earlier, Hardik. Focus, okay? I was showing it to you earlier also, but you missed it. This is the aircraft. This aircraft right now, how does it look to you? Straight and level. Okay, this is straight and level. From front, from side. Do you understand that, Hardik? This is
Yes,
called
sir.
straight and level. When the aircraft moves like this or like this, okay, this is called pitching. When it moves up, it's called pitch up. When it goes down, it's called pitch down. Are you following what is pitching?
Affirm, sir.
This is pitching. It has to be controlled. It has to be within certain limits. So if this is the horizontal, so the angle will be measured from this horizontal, like this. Positive, negative, nose up, nose down, pitch up, pitch down. So this is measured. what is the aircraft configuration like this through the artificial horizon. Okay, everyone, this is pitch. Achal, this is pitch. Pitch up, pitch down. From ahead, it will look like this: pitch up, pitch down. Are we following, everyone?
Affirm, sir.
Yeah, mainly Achal, Hardik, for you. Nandini, you also focus. What is roll? Now look at the aircraft. The aircraft moving like this to the right is called roll. Moving to the left is called roll. This is roll. From side, this is roll. We understand, Hardik, what is roll?
Affirm, sir.
This angle from the horizontal can also be measured. How many? What is the angle? So this is an angle right now. This is the angle right now. So the roll right, roll left. Roll and bank is the same. Banking is also this only. This is also bank. But whenever you bank an aircraft, it turns like this. You will learn in aerodynamics. So this is bank, this is pitch, and roll and bank are the same things.
Okay, sir.
Good. Keep asking, students. Good. Hardik had asked roll, bank, and pitch. Roll and bank are the same. Bank angle can be measured. Rolling is just the motion. Whenever aircraft rolls, we can measure the bank angle. It's like that. Okay, just a minute. I want to share it to you with you all right now only.
Sir, I had one more question.
Sorry, say again.
Sir, what does triple pointing altimeter mean?
Sorry, say again.
What does triple pointing altimeter mean?
Triple pointer altimeter. Okay. Altimeter have different, there are different types of altimeters. One is a digital and a single pointer, where we have only one pointer and we have a digital readout for what the altitude is. And the next one that we have is like a watch dial. In a watch, we have 3 pointers, right? Minutes, second, and hours. Similarly, in an altimeter also, we have 3 pointers. One pointer will show you hundreds of feet, one will show you thousands of feet, and one will show you 10,000s of feet. So there are 2 types of altimeter indicators. One is with single pointer and digital readout. One is with 3 pointers, showing you hundreds, thousands, 10,000s. Okay, that's a 3-pointer altimeter. Good job, Hardik. Very well. Students, any more questions? So in lecture 1 also, we are talking about the same. Okay. So if you are going through lecture 1 and lecture 2, then I am assuming that your basic principles of gyro are strong. And please do not give me bad answers when I'm asking you the answers. Give me proper specific answers. You have to prove yourself to me now about these basic principles. I want to finish gyro nicely in next 2 lectures. And the average time of the next 2 lectures can be 2.5 hours. Okay. But it depends upon the response I'm getting from everyone. You have time today, tomorrow, and day after tomorrow until 5 o'clock. Study, revise well. Even if you're not following or if you've not understood, you will understand. Give yourself some time. But try your best. Right now, your focus should be for navigation gyros. Sir has given me notes. I'll read those notes. Sir has given me handwritten notes. I will read those notes. Try to understand. I'll ask my doubts. Simple as that. All right. It's a very individual and a specific dimension of its own. Check your emails. You must have got it, everyone. I'll see you for navigation day after tomorrow. And as per the schedule tomorrow, I'll see you in your classes. All right, everyone. If you have any questions, please let me know via WhatsApp. And if you allow, I'll take a leave right now. Viral, I'll leave. Nandini, Achal, Hardik, Subhajit, Likit, Nukul.
Okay, sir.
Okay. Fine, everyone. Take care.
Thank
Bye.
you so much.
All the best.
Bye,
with the
sir.
class.
Thank you.
Thank you, sir.
Most welcome, everyone.